Shielded metal arc filler material. Gary A. Pace, PE, CWI, April 2019. We're going to talk in this one about filler metal designations and just a general good old rant in regards to shielded metal arc welding filler material. First off, oxygen is not our friend. I know this is kind of counterintuitive because all life is based on oxygen, but in materials joining and welding, oxygen is not our friend. Metals at high temperatures are reactive chemically with the main constituents of air, oxygen and nitrogen. Should the metal in the molten weld pool come in contact with air, porosity, oxides, and nitrides would be formed, which upon solidification of the molten weld pool could destroy the strength properties of the weld joint. So, knowing that oxygen isn't our friend and that we want to avoid atmospheric contamination of the weld pool, we want to keep oxygen from crashing the party. We want to keep oxygen out of our weld pool. This is the basis of welding most materials that you're ever going to run across. I use this as kind of a, I don't know, cheesy one-liner. Oxygen is not our friend, but that's a easy way to, think of, atmospheric contamination. We don't want oxygen in our weld pool. So, in knowing this, we got to go forward and think of how we're going to keep oxygen out of the weld pool and nitrogen. Knowing that oxygen is not our friend, it gets back to where does the weld metal come from? So we need to know where weld metal comes from so then we can figure out how to keep the oxygen and other atmospheric contaminants out of our weld puddle. So the welding process we're going to talk about today is shielded metal arc welding, otherwise known as stick. Shielded metal arc welding is basically, and I'm sure somebody's going to blow back on me and tell me I'm wrong or I'm a hillbilly for saying this. But basically, shielded metal arc welding is some powder on the outside of a coat hanger for carbon steel. I don't know what the material tensile strengths of your average coat hanger, carbon steel coat hanger would be, but I'm betting it'd be somewhere in the ball game of what you'd be able to use for welding, your basic farm implements or, garden variety carbon steels. That being said, shielded metal arc welding is a piece of wire with a flux on it. And some things I've read when electric arc welding first started, I've seen some shielded old electrodes that had string wrapped around them. Somebody back in the day figured out if you wrapped string around your electrode and you welded with it, it would burn. Well, in burning, it would chase off the oxygen and the nitrogen. And then some point somebody, and this is all hearsay and anecdotal, I haven't done a bunch of research into it, and then at some point somebody decided, hey, what if we wrap it with newspaper? So they wrapped it with newspaper and it caught on fire and, they were able to keep the, have better luck with their welds, have better outcomes with the welding. Well, and then that progressed into somebody setting up to manufacture, 6010, which is a cellulose-based flux, which is basically wood chips and paper, which when it burns, it kicks off, some gaseous fumes and whatnot, and is able to protect our weld pool from oxygen. So that's where our weld metal comes from. If we took a slice through our shielded metal arc welding electrode, we would have our steel core, which is basically wire, and we'd have a flux. There's a whole bunch of different kinds of fluxes you can put on the outside. But this would be an end view. You've got the flux on the outside and the steel core on the inside. So the standards specific to the shielded metal arc welding are like AWS 5.1. This is a specification for carbon steel electrodes for shielded metal arc welding. It's a little book of about, I want to say, 40 or 50 pages. You can see a picture of what one of these SFAs look like, these specifications for filler metal. And it's just a little book, a little specification that tells you everything that needs to be known about that specific material and how the people that are the manufacturers are going to make it. They have to follow those rules to produce that product and then put that particular product out on the market as, let's say, 7018. Um, so then you have SFA A5.5, which is for low alloy electrodes. It's a little different than 5.1, but it would be a 7018 with some extra alloying elements thrown in there. And 5.4 is for shielded metal arc welding for corrosion resisting chromium, chrome nickel steels. I think that's a fancy way of saying stainless steel. But here's a couple of pictures of some SFAs that I had in my library, and you can see that there's not much to them. There's a lot of information to them, but it's not a very thick 500-page book, these specifications. And they're good sometimes for looking things up. My friend left them to me, so I threw them in my library. E stands for electrode. The first two numbers indicate the tensile strength. The last. So for shielded metal arc welding electrodes for carbon steel, typical values for the first two digits are 60, 70, 80, 90, 100, and 110. Anything generally I see with above a 70, I throw up a red flag and got to ask myself how much preheat there is going to be, or if this thing needs to be post-weld heat treated in any way. So just something to think about. But I was going to say that third one where it says 10718, that's one of the strangest ones I've run across. Had a job years back, and one of our clients had a very specific formula for some welding electrodes that they needed us to use on their stuff. So yeah, there was actually a 10718. I looked at it a few times and was like, what is this stuff? Because you go from 118 to a 11018 to a 12018, and then there's this 10718. So there's a lot of different things you can run into out there in the world. So just a thought. So when we want to talk about shielded metal arc welding, filler metal electrodes, and the nomenclature to describe them. So this will be the starter, and then we'll get into some more complicated stuff. So the E stands for electrode. That's all it is. Electrode means we're going to run electricity through this filler material to get it to deposit into the weld joint. If we had other designations for like gas tungsten arc welding or gas metal arc welding, you have ER, which is electrode or rod. This isn't a rod. This is strictly electrode. This is a consumable electrode. It is going to be consumed. It is going to run electricity through it. So we've got the E as the first number. The second two numbers, the 70, the 7 and the 0, that's going to tell us our tensile strength. So the 70 indicates 70,000 psi tensile strength. The 2, that third number, the 2, indicates use for welding in flat, groove, or horizontal fillet positions. So we can't use this filler material in all positions. And then the 4, that last digit, tells us which type of flux coating it has. So this would be iron powder titania. So for positions, that third digit on the weld rod for shielded metal arc welding, you've got 4 different options that are going to be there, a 1, 2, 3, or 4. I've only ever seen a 1 or a 2. There is a 3 and there is a 4. I don't know how often you're going to run into something like a 70-48. which would be flat, horizontal, vertical, down, and overhead. But they do exist, and if you need to track them down, they're out there, but I just have never run across them. But realize it is possible. It's not a typo generally. Um, but that third digit is just going to tell you the position. So the two biggies that I've run across is a 1 there, like with 6010. It's, 60,000 tensile strength. The 1 is telling you that it's in a flat, horizontal, vertical, or overhead position, all positions. And then the last digit is that flux type. So then the other one I've seen a few times would be 7024, which is flat and horizontal only. But I've never run across the 3 or the 4 in that third digit. So there's some electrode characteristic groupings. Um, they're grouped according to their performance characteristics. So you have like a fast freeze material, weld material, which would be mild steel, quick solidification of the weld pool, deep penetrating, recommended for out of position welds, and it's got a really deep digging arc. This would be like a 6010. You've got fast fill, which are high deposition rates, stable arc, thick flux, flat position only, and horizontal laps. So that's telling you that would be something like a 7024. A fill freeze, general purpose electrodes, they have the characteristics of a fast freeze and a fast fill, so that's kind of a middle ground. Then you've got low hydrogen, welding characteristics of a fill freeze. So this would be something like a 7018, and they're designated for medium carbon and alloy steels. So you've got some different options here, and that's why when you're learning to stick weld, the way you're going to manipulate the welding rod with 6010 is completely different than how you would run something with E7024 or 7018. So here you can see we've got one that's a little bit more complicated. So we've got E8018-B1-H4R. So the E, of course, is a consumable electrode. We're going to run electricity through this to get it to deposit in the weld joint. The 80 indicates 80,000 psi tensile strength, and the 1 indicates use for welding in all positions. The 8 indicates that it's a low hydrogen electrode, flux type. Well, we've got that B1 in there. Well, anytime we get to a situation where we've got a letter and a number in there, that's telling us what kind of extra goodies have been added to the flux and the weld metal. That's telling us that this one's telling us that we've had some chemistry added, some extra elements added, some alloying elements added. That's going to give us 0.5% chrome and then another 5.5% molybdenum. So this would give us some enhanced, mechanical properties down the road that if we just used regular run-of-the-mill 8018, we wouldn't get to. So then the H4 signifies the maximum amount of hydrogen that will be diffused from the rod. And then the R means that the rod is moisture resistant. So you can have different numbers for that H4 or H. There's different numbers that you can have in there. I haven't dealt with them in a while, but I do remember that we used to specifically buy material that had to have a certain hydrogen diffusion quantity. Shielded metal arc welding electrode designation. So here we've kind of merged our two tables. On the left-hand side, we've got the type of coating and current. And then on the right-hand side, we've got the alloying content of the weld metal deposit. So you can see, once again, we've got an example, E6010, which would be cellulose, all position, DCEP, 60 KSI minimum tensile strength. 7018 would be low hydrogen, all position, AC or DC, electrode positive, 70 KSI, ultimate tensile strength. Well, then we get down to that third one and we tack on the A1 from the right-hand alloy content of weld metal deposit. And that A1 just says we're going to get 0.5% molybdenum into our weld metal deposit. So you can see there's a whole bunch of different alloying contents. So you can have an E7018 C2, an E7018 B3, an E6010, C3. I don't know if you could do that, but you'd probably go to a 7010 C3. So, and then we've got G down at the bottom, which is, as I'll state again later on, but G is a special recipe. So if we run across one of these filler materials where it's got 8018 C2 or 7018 C3 or something with a designation behind it, it's just telling us that it's a filler material that's got extra alloying elements in it to give it some kind of additional mechanical or corrosion resistant properties. They've added another, like I said, alloying element to help, give it a chemistry that is above and beyond what you could get from the chemistry of the deposited weld metal from the, like a regular 7018. And if you see the G down there, that's special recipe. Every now and then you'll run into something that's got a G on it. So if you run into something that's like with a 7018 and then there's a G behind it, you're probably wondering, what is this stuff? Well, it's still 7018, but that G that's the suffix, I guess. Yeah, that would be the suffix. The suffix there, it tells us that this is a special batch of stuff. We didn't order off the menu when we ordered this particular item. We told the waiter, this is how I want on my pizza. And we didn't just get a pizza with pepperoni and cheese. We got the special Lithuanian goat cheese and some kind of special Sicilian sausage and some special Spanish ham from a certain region of Spain and some kind of crushed kale or whatever. That's what we got on our pizza. We didn't get a run-of-the-mill Totino's pizza or Little Caesars and you go in and pick up the little take and bake or whatever they are. This is a special order. So they throw the G on there to let you know that it is a special order and that heat and lot number was ordered by a very specific customer and they wanted a certain chemistry in it. So this is from Table 2 in SFA 5.5 or 5.5M 2013 Section 2 Part C. This is from ASME. You can see that we've got the chemical composition, the chemistry for an E17 or 7018A1. So our carbon content would be 0.12. We'd need a 0.9 for manganese. Silicon, phosphorus, and sulfur, those would be our maxes. And then our moly would have to be, our molybdenum would be between 0.4 and 0.65. Well, if we order some 7018G, we've got to have a minimum of 1.00% manganese, 0.8% minimum silicon. There's our phosphorus and our sulfurs. And then it's telling us what we have to have for the rest of our materials, our alloying elements. We've got to have a minimum of 0.2 moly, 0.5 min for nickel, 0.3 for chrome, 0.10 for vanadium, and 0.2 minimum for copper. So as long as they've got reach those, this thing can be all over the board. So it goes by heat and lot number if you're ordering material with a G. Because if I order a G, a 7018G, it's not going to be the same as the 7018G that you order unless our chemistries match up exactly. So that's with the G. The G just tells us we can order whatever we want. We can order off the menu, but this is the minimum amounts of what needs to go into a G. So two different separate G's. If you bought some G from ESOB and you bought some 7018G from ESOB, and then you bought some 7018G from Lincoln, they are not necessarily the same thing unless those chemistries match up exactly. You could have two batches of 7018G from ESOB and they're not the same stuff. G is just telling you this stuff was a special batch of weld material made for a specific client with a specific chemistry in mind. G, what does this mean? If a G is used for the chemical composition designator, it signifies that the chemical composition and mechanical properties are not specified and are as agreed upon between supplier and purchaser. This material needs only a minimum of one of the elements listed in the AWS A5.5 table for chemical requirements. Basically, if there is a special recipe for filler material that you would like to purchase, you can order it. For example, as a E7018G, and the filler metal would have your special recipe and would not be the equal to all other E7018G electrode combinations that might be made by that manufacturer or another manufacturer. So it's a special recipe. You tell the manufacturer, I want this to go in there, and they will make you a heat and lot number of that filler material with your chemistry requirements. Electrode size. Electrodes are available in a variety of lengths and diameters. The diameter of the electrode refers to the diameter of the uncovered wire. So it's not, you don't measure the diameter of the flux, it's the diameter of the wire. Because something like 6010, a filler material such as 6010, has got a very thin layer of flux on it. And then if you go to a 7024, it's got a really thick layer of flux on it. So those two materials, even though one is significantly larger in diameter with the flux, if you call out for, I'm trying to think of a good number, 1/8 inch material on both of them, the wire diameter is going to be the same, even though the flux diameter of the E7024 is going to be significantly greater than the flux diameter of the E6010. Electrode storage. Electrode storage is ultra critical. Electrodes are damaged by rough treatment, temperature extremes, and moisture. They should be kept in their original container until used. They should be stored in a heated cabinet or a rod oven that maintains them a constant temperature. That's for low hydrogen only. The storage of low hydrogen electrodes is very critical. They're designed to reduce underbead cracking in alloy and medium carbon steels by reducing the amount of hydrogen in the weld pool. The flux is hygroscopic, which means it attracts moisture, which low hydrogen, we don't want moisture. The moisture in the flux also causes excessive gases to develop in the weld pool and causes porosity. So this is why it's very critical to take good care of your electrodes. Don't stack the boxes in water and, keep them in, an old refrigerator with a light bulb in it. I mean, that kind of keeps them a little bit warm, but generally for grown-up situations, for situations where there's a great degree of quality control involved, you want to have a rod oven. And you want to segregate your filler material generally, so you have some kind of filler metal control program so you don't just have welders picking and choosing what filler material they're going to use to weld. So electrode storage, crucial element of the welding universe. Here you can see an example of some 7018 being stored in a rod oven. We store 7018 in a rod oven because we don't want to, because the material is low hydrogen, the filler material is low hydrogen. And we do not want our flux picking up a bunch of hydrogen or water or moisture, and then when we strike an arc, depositing that into our weld metal. So consequently, we have rod ovens in the welding industry. You generally have them segregated. You don't put 5 different kinds of filler metal in the same rod oven unless you're a smaller operation or something. But I worked for a big contractor, and in our rod ovens, we had it broken out by filler material size, heats, lots. There was a whole bunch of different stuff going on. Another outfit I worked for, we did a lot of work for the military and whatnot. So we had everything segregated, heats, lots. It was very, very controlled. The filler metal control program was very precise. Okay, we had a little chat about shielded metal arc welding, the designations of the materials, what can go into them, hopefully cleared up a couple of the nuances in how these materials are labeled, numbered, and the system that is utilized by the AWS and ASME to designate filler materials for shielded metal arc welding carbon steel. My name is Gary A. Pace. I'm a PE CWI, Katy, Texas 77450. Need to track me down. There's the email on my website. Take care.